representing ratios with diagrams. So we're going to be looking at some different diagrams that we could use to talk about ratios in some different ways and dig deeper into ratios. So today's goals, I can draw a diagram that represents a ratio and explain what the diagram means. I can also include labels when I draw a diagram representing a ratio so that the meaning of the diagram is clear. Just like everything else in math, you always want to make sure that you get those labels. So I have your two statements written down, today's date, and you're ready to move on. All right, so before we get into that, let's do a little quick thinking about uh, using dividing by 4, multiplying by 1/4. See if you notice what goes on. So 24 divided by 4 is, yeah, I hope you had 24. Oh, not 24, 6. 24 divided by 4 is 6. Woo. What about 1/4 times 24? Actually, that comes out the same, doesn't it? Because you've got 1 over the 4. Remember that you put whole numbers over 1 when you multiply by a fraction. 24/4. And you still end up with 6 for an answer. Is it the same if we just turn those two around instead of going 1/4 times 24, 24 times 1/4? Yeah, it's the exact same answer. What about 5 divided by 4? Well, think about it. So 24 divided by 4, we could have rewritten as 24 fourths. Remember, those fraction bars are just another way to do division. And this relates into what we're talking about with ratios as well. So if I've got 5 divided by 4, I can actually write it as 5/4 and have the same thing, right? So these end up, all this fraction work that you've done before is in its own way a type of ratio looking at parts per some other part. So being able to fluently do your work with fractions is really going to help you when it comes to all this stuff with ratios. All right, so let's take a look at some Snapcube pictures and see if we can figure out a few things. So if I had a diagram here, these two diagrams could represent the same thing. In one way, I've got 2 green squares representing 2 green. Could also have 2 squares and have a G in them to represent 2 green. I could just have the letter G's, 2 letter G's to represent green. So a diagram is basically a representation of something else. So on this next part, I want you to sketch out and figure out your diagram for what we've got next. So I've got some snap cubes here, and I want you to choose 2 of the colors, and I want you to draw a diagram that represents them in your notebook. So let's say I was going to do I was going to do, let's say, these red cubes to the pink cubes. So I've got 1, 2, 3, 4, 5. So I would need, and for my diagram, I'm just going to use 5 R's to 3 of the pinks. Now I could have drawn 5 red boxes and 3 pink boxes and shown the same way. I could have drawn 5 squares with an R in them, 3 squares with a P for pink. So other than this particular example, I want you to write out your own. Great. So should have shared with me which ratio you chose to do. Let's look at a few of these. So let's say if I had the yellow, 1, 2, 3, 4, 5. I had 5 yellow. Oops, hang on. And let's go with the green. I got 2 green. I could look at this and talk about the ratio of the yellow to the green. For every 5, for the 5 yellow that I have 2 green. I could do something else, like with the blue here. I could say, let me switch a color here. I could say that I have 2 blues for 1 of the blacks. It's just not going to show up very well if I do it like that. Hang on. So I have 1 black cube. Oops. That was annoying. So I have 1 black cube for 2 blue cubes. I have 3 pink for 1 black. I have 2 green for 5 red. I have 2 blue for 5 yellow. There's lots of different combinations as far as the ratios that I have. Lots of different ways that I could look at that. And really, the ratio here is just talking about how those things relate. Let's think about paint. So if you talk about paint, in this situation, we've got Elena mixing 2 cups of white paint with 6 tablespoons of blue paint. Yes, I know these are green, but again, it's a diagram. It doesn't have to actually show the color. It's just showing that we've got 2 white paint cups and 6 blue paint cups. So now that we know this, let's see if we can figure out if some of these statements about this are true or not. So if I look at all of these, which of these statements are going to be true? And I'm going to have you guys mark actually in your the answers here, which ones of these are the correct ones. All right, let's take a look at which ones are true and which ones are not true. So again, 2 cups of white for 6 total blue paint. Can we say that there are ratio of cups of white paint to tablespoons of blue paint, 2 to 6? Yeah, I think we can. That's pretty easy because we have 2 cups of white, 6 of the blue. Every cup of white, there are 2 tablespoons of blue paint. That doesn't quite match, does it? This next one, 1 cup of white paint for every 3 tablespoons of blue paint. Can't we think of that if we just match this up here? So 2 to 6 would be the same as 1 to 3. Does that make sense? Are those equivalent? Yeah, think about fractions. If I made 2/6, I could reduce that down to 1/3. So a 2 to 6 ratio is equal to a 1 to 3 ratio. 3 tablespoons of blue paint to every cup of white paint. That does work kind of. And the reason why I'm going to say kind of is here we've got the white paint listed first before the blue paint. So really, we should be going with the 2 cups to the 6 tablespoons, that kind of way. But this still does talk about the ratio in a way that would help us understand. What about for each tablespoon of blue paint, there are 3 cups of white paint? Yeah, no, that is not at all what we have here. 6 tablespoons of blue paint, there are 2 cups of white paint. Again, this is like the other one. It works, but it's not the same ratio. It gives the correct numbers and the correct pairings, but as we've got it pictured in here, we're more talking about that the white paint related to the blue paint. Same with this last one. It still talks about in the same way, but it's slightly different. Our best choices here are going to be, with A and with C. Those are our absolute best answers, but these other ones could be possible. Okay, one more for you. I want you to explain this in a sentence or two. It says at least 2 sentences, but I just need at least a sentence in the answer box over there of how you could explain Jada mixing 8 cups of flour with 2 pints of water. So you could do something like this. So we've got, as far as how it would look, I could say that it's 4 cups of flour to 1 pint of water, right? Or I could say that it's the 8 cups to the 2 pints. So I got the flour. Hang on. I've got 8 cups of flour to 2 pints of water, or I could look at it as saying that I've got 4 cups of flour to 1 pint of water, and that for every 4 cups of the flour, I have to have 1 cup of water, or 8 cups of flour to 2 cups of water. So it's the same sort of thing either way, but I should be talking about those cups of flour first before I talk about the water. The other way around still works. So what are some good things to remember? Well, when you're drawing a diagram of a ratio, it should match up with whatever you're representing. Not only should it match up, but it should be labeled or it should be obvious as to what it is. Think back to here where they had the white cups or white paint cups labeled as that and the blue tablespoon paint labeled in a different way. They had the labels off the side and then pictures to represent it. It's one of those things where you need to make sure that what you're doing labels so people can understand. Diagram can help you make sense of something because it's a quick, easy visual way to see what's going on with a relation. Okay, so that's it. If you have to go back and get something, please do so. Otherwise, go on to your practice.